Critical thinking, sets and Venn diagrams. Let's begin with some basic definitions. A set is a collection of objects. The individual objects are members of the set. In this class, we are specifically going to be interested in describing not simply members of a set, but the relationship among multiple sets. To recognize the relationships between sets, we often rely on Venn diagrams. The English logician John Venn invented a visual way of describing the relationship among sets. These diagrams, called Venn diagrams, use circles to represent the individual sets. Let's take a look at the three different relationships between sets that we will encounter in this course. First, we have a subset. Set A is a subset of set B if all members of set A are also members of set B. Notice if you take a look at the Venn diagram, the two circles or the two sets, set A and set B, one is completely inside of the other. Second, we have disjoint sets. Set A may be disjoint from set B if no two members are in common. Once again, if we take a look at the image on the right hand side, set A and set B have nothing in common with one another, therefore the two circles are completely separate. And finally, sets A and B may be overlapping sets, meaning that the two sets share some of the same members. This class will focus mainly on overlapping sets, since they are more interesting. Let's take a look at interpreting the different aspects of a Venn diagram with two sets. First, we need two sets to consider. So let's create a Venn diagram to understand the relationship between doctors and women. First, we want to begin with what we call our universe. This is merely all of the members or elements we want to consider for this particular problem. Typically, the universe will be clearly stated within the wording of the problem as the number of individuals we studied, surveyed, or responded to any given question. We start a Venn diagram with drawing a rectangle to represent our universal set. The number of members we will consider for this universe should be clearly marked in the upper right-hand corner. This should become more intuitive in actual examples involving counts. Once we have our universe clearly defined, we can begin with our sets. Let's create a circle to represent the first set, doctors. Next, we'll create a set to represent the set of women. Here's where we need to decide how these sets relate to one another. If we had subsets, that would mean that all doctors are women, or vice versa, all women are doctors. Disjoint sets would mean that no doctor is a woman, or no woman is a doctor. Neither of these apply to life as we know it because, in fact, some doctors are women, or vice versa, some women are doctors, indicating that we have overlapping sets. Let's recap the different areas of our Venn diagram. First, we have the set of all doctors in our universe. We then move on to the set of all women in our universe. Notice the difference here with this set. This set indicates the set of all doctors that are not women, i.e., male doctors. We also have the set of women who are not doctors. Notice in our overlap, this indicates the set of all women that are doctors. Notice the orange region is shared by both sets. This is typically stated with an AND statement. The overlapping region consists of all members that are doctors and are women. The green is the set of individuals who are not women, nor are they doctors, i.e., men who are not doctors. And finally, we have the set of individuals that are doctors or women. Let's see if we can take an actual example and follow along by identifying all the regions of the following Venn diagram. We see that there are 81 people at the party. In total, there are 37 men at the party. 22 of those men do not share the other characteristic, being under the age of 30. There are a total of 31 people at the party that are under the age of 30. 16 of those people at the party that are under the age of 30 but are not men, i.e., there are 16 women at the party that are under the age of 30. There are 15 men at the party that are also under the age of 30. There are 28 people at the party that are not men, nor are they under the age of 30. i.e. there are 28 women at the party that are over the age of 30. There are 50 people at the party that are not under the age of 30. There are 44 people at the party that are not men, i.e. there are 44 women at the party. Let's try an example on our own. Of the 45 theater performances that a critic reviewed, 23 were comedies. She gave favorable reviews to 8 of the comedies and unfavorable reviews to 12 of the non-comedies. How many comedies received unfavorable reviews? Pause the video here to try on your own before moving to the solution on the next slide. Let's take a look at the solution. We are told that the critic only reviewed 45 performances, so this is our universe. 8 of the favorable reviews were also comedies. Since 23 of the 45 performances reviewed were comedies, and 8 have already been accounted for, 23 minus 8 leaves 15 comedies that were not given favorable reviews. We are told that 12 unfavorable reviews were given to non-comedies. All we have left to find is how many favorable reviews were given to non-comedies. Remember, our universe is all 45 performances. Thus far, we have accounted for 35 reviews. 15 plus 8 plus 12 gives us 35. Thus, 10 non-comedies must have been given favorable reviews. Now that we have completed our Venn diagram, we can answer the question: how many comedies received unfavorable reviews? The answer is 15 comedies were given unfavorable reviews. Let's take a look at another example. All cyclists who competed in the race were given a drug test. Of the 18 cyclists who tested positive, 3 finished in the top 10. 25 cyclists tested negative. How many cyclists were tested? Take a moment, pause the video, and try this on your own before moving to the solution on the next slide. Let's take a look at the solution. We are told that 3 of the top 10 finishers also tested positive for drugs. Therefore, the rest of the top 10 finishers, 7, must not have tested positive for drugs. A total of 18 riders tested positive for drugs, and since we have already accounted for 3, 15 remain. 25 cyclists did not test positive for drugs, so that leaves 18. Remember, 7 of the top 10 have already not tested positive. Therefore, we have a total of 43 cyclists in all. Now that we have completed the Venn diagram, we can answer the question: how many cyclists were tested? 43 cyclists were tested for drugs.